guys, welcome back. Third edition, Algebra 1, the third edition, Saxon Algebra, blah, blah, blah. You got it. We're on lesson 91 today, 91. What we're going to be doing is talking about, we need to do a quick refresh on real numbers. We got two types of numbers, real numbers, non-real numbers. You'll find out more about those in Algebra 2, also called imaginary numbers or complex numbers, all those different things. Today we're going to talk about real numbers. Quick refresh on this. If you don't remember, hop back to one of the other videos. Just search on real numbers or rational, irrational numbers. We have rational and irrational numbers are our next breakdown here. And irrational numbers are things like pi, square root of 7, things like that. Rational, notice the word ratio, anything that can be written as a fraction. So 1/3, 3 over 4 of those fractions, 0.75, 0.3 with a line over it. Anything that can be written as a ratio goes there. Inside of our rational numbers, we have, let's work our way out. The first thing we have are natural or counting numbers. Natural / counting. Those are things we use to count. 1, 2, 3, ... Okay? Now, whole numbers are all these natural numbers plus 0. So 0, 1, 2, 3, and so on. Integers are natural counting numbers, whole numbers, and the opposites of these naturals. So it's -3, go in the other direction, -3, -2, -1, 0, and so on and so forth, okay? So that's going to be important today when we talk about these because the domains are real, non-real, you don't have any non-real, but you have integers, things, whole numbers, things like that. So let's talk about how we're going to graph these. This is just an inequality, but the way that we want to do this is we need to get that x by itself, and there's a 1 in front there. So we're dividing by a -1. But guys, when you divide or multiply by a negative with an inequality, you have to flip the sign. So now these guys cancel out, and I have x is less than or equal to, I switched it to -2. All right, so now we're going to graph this guy. Draw your number line, throw this guy in the middle, -2. Give it context by putting a number on either side. If you're right-handed, it's kind of helpful because you write and it goes up larger. This has an equals here, so it's going to be a closed circle. The arrow points like this, so we're going to shade in that direction. A couple things here. Always make sure your variable is on the left-hand side. If it's not, you need to rewrite it and flip it around so that it's correct. That way this little arrow thing works. That trick will work. All right, let's take a look here. We want to get this x by itself. So we're going to -4 from both sides. Now what we have is -x is less than or equal to 2. But we've got to flip that around. Divide by -1, divide by -1, I get x is greater than or equal to -2. Oh, shoot, you know what? We got to go back up here. On all real numbers, that's what this is. Real numbers are things like decimals and fractions and things like that. This guy with integers, though. So again, we're going to do our number line. We've got -2 here. We give it context by putting 1 over here, 1 over here. Now, this includes -2, so closed circle, but remember, it's integers. So, in fact, I'm going to stretch this out just a little bit further here so you can see 0, 1. Now, remember, integers are negative numbers. It's the natural numbers plus their opposites plus 0. So, this is just going to be dots on here, so on and so forth. It's not going to be all the garbage in between those decimals and those fractions, okay? Looking at this guy right here, we've got -3x. Okay, so we're going to -4 from both sides. When we do that, we get -3x is less than or equal to 9, looks like, okay? Divide both sides by -3, but hey, we're dividing or multiplying by a negative. Flip your signs. These cancel out. X is greater than or equal to -3. Again, we're doing all real numbers, so we're going to give our context here. We're going to do -3 right in the middle, then how about -2, -1, 0, and then -4. You don't have to put too many here, but I think it's helpful. So x is greater than or equal to -4, or -3, I'm sorry. So it's a closed circle because it's equal to. You see how this arrow goes like this? We're going to be shading in that direction to match that arrow like this. Some people shade like this. Other people draw up and draw a little arrow. You can do that too. Either way works. But that arrow trick only works if it's the variables on the left side, so make sure that's correct. All right, guys, so for the kids that are in my class, you can skip spheres, but I'm just going to do a quick rundown for you so that you can see it if you want. No big deal. Volume. Volume, there are better videos out there explaining why we get that formula, and I highly encourage you to watch, like, I'll see if I can find some and link them in the description below. So for right now, I'm just going to plug and chug on these formulas, but there are some really good explanations as to why we get that formula. So I encourage you to watch those. So the volume equals 4/3 times pi times the radius cubed. So 3 to the 3rd power. Okay, so I'm going to rewrite this to make my life a little bit easier because this is all upstairs, right? So we get volume equals 4 times 3 to the 3rd pi over 3, which we know is to the 1 power, right? Well, this cancels out, and this guy is a 2. So now I have volume equals 4 times 3 squared pi, okay? I should have worked downwards. I'm sorry about that, guys. So that means volume equals 3 squared is 9 times 4 is 36 pi. And my units are centimeters, and we're talking volume, so we're filling it up, so it's going to be centimeters to the 3rd power. Centimeters to the 3rd power. Okay, so the next one, and these ones, my class, I don't care if you leave it like this, but some teachers want you to multiply by pi, so make sure to do that if that's the case. All right, finding the surface area, here's our formula right up here. Surface area equals 4 times pi times the radius squared. Our radius is 4, so it's going to be equals 4 times pi times 4 squared. 4 squared, we know, is 16, but there's a 1 here, right? So really, it's 4 to the 1 and 4, that's 4 to the 3rd pi. We know that's 64 pi. So that will be, and then we come up here, we're like meters. Okay, meters squared, because it's surface area, so it's the outside of that. Okay. All right, now let's do some practice problems, I think. I don't remember. Yep, practice problems. So go ahead and attempt these practice problems on page, those are the first 3, on page 381, and then come on back. There's the sphere ones. All right, so divide both sides by -1, -1. We end up with x, flip your sign, is less than or equal to -5. Then we need all real numbers, so we're just going to graph that. When it's all real numbers, it's pretty easy. You just do -5, give it context, so -4, -6. This is going to be a closed circle, and it's going to be pointing in that direction, so there you go. All right, looking at this next one. First things first, this is not less than or equal to. That means just straight off the bat, switch it. So it's going to be 2 minus x is greater than 1, because not less than or equal to means flip the sign and get rid of that equals. -2 from both sides, we get negative x is -1, is greater than -1. Divide both sides by -1, and we end up with x is less than, because now I've flipped my sign, +1. This time we're talking integers, so let's make sure we're paying attention to that. I probably messed up that last one, to be honest with you. No, I didn't. Good. Okay. We're going to put this guy in the center, give it context. So there is a 1, and then we're going to go 2, and over here is going to be 0. Because this is integers, I'm actually going to do a little bit more, right? 3, this is -1. All right, so it's an open circle at 1 because it's not equals to, and then it's less than because it's going this direction, and it's integers only, so it's going to be 0, -1, and so on and so forth, okay? All right, so for this guy, we want to get that x by itself, so we're going to -5, -5. -3x is greater than -4. Divide both sides by, and see, minusing doesn't matter. You don't change the signs then, only multiplying and dividing by a negative. So then that's going to be x, but we divided by a negative, so flip your sign, is less than 4/3. Negative divided by negative is a positive, so 4/3. However, x is less than, for me, it's easier if I put this into mixed number, right? So 1 1/3. Okay, so we come back over here, and 1 1/3 comes between 1 and 2. So here's 1, here's 2. I'm going to give it context, 3 and 4. Oh, whoops, what am I doing? Putting a 4 over there. 3 and 0. There we go. Okay, this is an open circle on 1 1/3. So 1, that's 1/3, and that's 2/3. So I'm going to put an open circle here, and then it's going to be all integers that are less than. So it's going to be 1, 0, and, you know, just for sake, you can extend this guy out a little bit, -1, so on and so forth, okay? All right, so for our spheres, we're going to find the volume and the radius. So we've got volume equals 4/3 pi times the radius cubed, or yeah, radius cubed, so 4 to the 3rd power. So that gives me volume equals, upstairs I have 4 to the 1 and 4 to the 3rd, so that's 4 to the 4th, pi over 3. 4 to the 4th is not what I can remember off the top of my head, so 256. So I get 3s. So 256. So this equals 256 pi over 3. All right, well, this is 3 obviously doesn't go into 256 because this is base 4. So we can't reduce this at all. What we can do is just do the actual math on this. So we do 256. So if we did 256 times pi, which is, there it is. I have to hit shift, and then I got to hit this guy. So pi equals all that garbage, and then we divide that by 3. We end up with 268.1, right? So 268, is that what I said? 0.1, yeah, okay, 0.1. And this is inches, and we're talking volume, so it's going to be inches cubed. All right, so let's do surface area. We have surface area equals 4 pi radius squared. And for the sake of this, I'll just do that. Our radius we know is 5, so we get 25 times 4 is 100. So our surface area equals 100 pi feet, and we're talking surface area, so feet squared. I don't care if you leave it in this format. It doesn't bother me, but if otherwise you multiply it by 3.14. All right, guys. Anyway, that is it for this lesson. If you have questions, let me know. Otherwise, we'll see you next time.